share knowledge with us on how to go about building and renovating our homes to make them more sustainable. On our panel, we have Steve Wright. I jokingly call him my cousin.
Wright.
Scott Wright, I'm sorry. Scott Wright, who I jokingly call cousin because we share the same last name. But he has a home building ownership here in Cleveland. He also does the spray foam installation in our community, so a wonderful source of information as well as a wonderful source for having the work actually done. We also have on our panel tonight Tom Calloway, who is with JB Solar. And if you're interested in putting some solar panels on a home or business, Tom is the one you want to talk to, and I'm sure he'll talk to us about the options they have available and what that means to our planet. And then last but not least, we have Mr. Jeff Christian, who is an amazing building science expert. And he has done wonderful work with Oak Ridge and many of TBA and many other agencies, and currently you're employed with Strategy. And so he's going to provide us with additional information on things that you can do as you're building or renovating that will make your home more sustainable. While you might pay a little more on the front end, the payoffs over time are worth the energy and the efforts and the finances that you put in. So without further ado, I'll turn it over to these gentlemen who will share their information. And I should make sure I say that this program is provided by a wonderful grant that the college was able to receive from ARC, the Appalachian Regional Commission on Energy.
You want to go first?
Yeah, I'll go first. Like I said, my name is Tom Calloway. I represent JBC Solar in Athens, Tennessee. We've been in the solar business for about 4 years now. The way I got involved was we're a traditional contracting company, and we got involved in the TVA Energy Right program, where we would go out and do home audits for folks. And part of that certification process is we had to take a class here at Cleveland State to get certified, so we knew what we were doing. Just like any other, like an electrician would learn how to do electricity, we had to learn how to go into a home and check, HVAC unit, insulation, and we could then make recommendations to that homeowner as how to make that home a little more energy efficient. About that same time, TVA was getting into the solar program. They were starting the generation partnership programs, and they were offering a grant to individuals, businesses, or individuals that wanted to explore solar here at the Cleveland State, at their technical department. So we signed up. It seemed like a natural next step. So we took that next step and just really got excited about solar. Being in the construction business, it seemed to kind of go hand in hand. We could make those energy efficient recommendations. We could do those energy efficient recommendations for them. But then we had an add-on product. Because we are a business, we're out to sell and we're out to service customers. So it just was a natural next step for us. So getting started in that, working closely with TVA and in their generation partnership program several years ago, it started. They have paid a 12-cent premium, and we had a 1 megawatt limit, I think, in the first year. Got a lot of interest in it. The way TVA was trying to fund this was through, you could buy renewable energy credits on your electric bill. I don't know if anybody's ever looked on their electric bill, but if you look at the very bottom, you can buy a sustainable, renewable credit. And that was going to fund the program. Well, the interest in the business side of selling solar and developing solar was a lot greater than the consumer side of buying the credits through TVA. So TVA had to step back and take a look and say, okay, we're getting a lot more people on this program. We're paying out a lot more money than people are paying into it. So they limited our size down to about 50 kilowatts. And that seemed to kind of put the brakes on the program, a little bit more control. So that worked out well. Now TVA, once again, they really haven't got the consumer end of the funding from the electrical utilities to help pay for that program. However, all the private companies like JBC Solar, Lightwave Solar, and all those guys being business-oriented, they went out and promoted solar. Went out and sold it, brought in outside investment, worked closely with economic development, communities, libraries, schools, Cleveland State universities, those types of entities really promoting the solar. TVA still paying out more money than they were bringing in. The drawback, and some of you guys may agree with this, is having a government entity run a corporate entity, it's not a really good fit. A lot of the TVA decisions are politically motivated, so a lot of the funding comes from a private sector. It needs to be really a free market area. But anyway, JBC Solar has been promoting solar, and we install, design, and repair solar systems. So in the last 3 years, we started out with very small 3 kilowatt systems, and the growth has just been tremendous. I think our first year we did $50,000 in business. This year we're looking to do $5.5 million in business. We just signed a contract with a local developer here in Cleveland. He is going to build a 700 kilowatt privately held system. It's a $2 million. It's going to be the largest privately held solar system in the state. The development that he has is he has built very high efficiency homes. He took an old cow pasture basically, it's 40 acres. He built homes in a semicircle, and in the middle is going to be a solar array. We'll have a little pathway through so folks can actually see where the power is that's powering their homes. So the interest in solar has really blossomed over the last 5 years. But having touted solar and how wonderful it is, I'm really firm believer that these two gentlemen's jobs should come first before solar. If you can become more efficient, then you don't have to have as much solar. The more efficient you can build your home on the front end, the less solar, the less energy you have to offset in the vacuum. So it probably would have been a good idea for these guys to go first, but he's got his presentation. We're going to let him do that, so we were stepped out of the way, so I kind of stepped up here first. So the energy efficient side is, and I don't want to detract anything from solar, but in my mind, it's more important to be efficient than it is to just produce energy to offset what you're wasting. It doesn't make any sense. If you run the air conditioner and it's a 15-year-old unit, you run it 70 degrees all day and it's just leaking it all out the window, and you got a $500 a month electric bill, and then you think, well, I'm just going to go buy a solar system that'll make $500 worth of electricity. Sure, you're offsetting a little bit of your carbon footprint from the coal, the TVA, the gas, the nuclear, but you really have kind of defeated the purpose of being energy efficient. You're not efficient. You're just substituting where you're getting your electricity from. So I would say, first of all, get efficient. Go call TVA, call your local utility company. They will do an energy right audit for you. Typically, depending on the utility, it may be free. Some of them charge, I think, $100 to do it.
I just got one for $50.
50 bucks.
It's 150, and right now there's a special deal.
So, yeah, exactly. So it's very affordable, and they'll have a company like myself or Jeff's company come out and they'll do an audit for you, and they'll tell you, your air conditioner's 22 years old. It's killing 20,000 kilowatts a year. By making a small investment into a high seared heat pump, you could lower that kilowatt hours. You got no insulation in the floors. So, you can make that investment in this. Those small investments will have big payoffs in the end. And then at that point, once you've got your efficiencies taken care of, then we'd like you to call us. Because then we can help you take that next step, which would be solar. Having said that, some of the benefits people ask is, well, solar's really, really expensive. It's so expensive. And I don't think I can afford it. Put it in perspective. If you took your average electric bill from when you graduated high school or you first got your apartment when you were 21, and most of us are hoping to live to 60 or 70 years old, the amount of money that you would spend over that lifetime is close to $500,000. A lot of folks don't realize it because they're only sending out $100 a month or $200 a month. You add that up over 40, 50 years, it's about $500,000 that you're paying to your local utility, and you're renting that energy from them. And they're going to raise that rate every year. Nobody's rates ever go down. So, if you make an investment in solar today, a solar system 6 years ago, and I'm going to backtrack a little bit, and I can reference TVA's website. When they first came out with solar, the national average of per kilowatt of electricity cost for a solar panel was around $8 a watt. So if you wanted a system, let's say at 3 kilowatts, that'd be make 3,000 watts of power for you at any peak given hour, which typically is about $50. If you rationalize it out, kilowatts to dollar hours, 10 cents a kilowatt hour for TVA, that system would cost you almost $40,000.
Now, would that system be big enough to do a house?
No, it would offset about $50 of your electric bill.
Oh, okay, okay.
So that 3 kilowatt, today that same that $8 per watt, you know, $50,000 investment would produce $50 worth of electricity. It'd take you 20 years to pay it off. The cost of the solar in the last 5 years, because of the involvement, the manufacturing sector, the public sector, consumer drives production. If the consumers want something, companies will make it, and that's just how it is. The cost per watt now, we're installing that same size system at about $2.25 a watt. So our systems, a 3 kilowatt system, if you take advantage of the tax credits that the government gives you, they give you 30% of that back in a tax credit. With the TVA Generation Partners buyback, TVA buyback with their generation partnership, all of our green electricity that we produce at the retail rate plus a 12-cent premium tacked on top of that. Now they're in the transition stage now, they're making some changes like they do every year because they're losing money on it. But that system would pay for itself in 7 years. And you've locked in your energy cost in today's dollars for the next 40 years. So you've just bought 40 years of electricity for $20,000 versus 40 years of electricity or 30 years of electricity at a standard retail rate where you might spend upwards of $200,000 or $300,000. Does that make sense?
But you're talking about $50 worth a month.
I'm just using 3 kilowatt as a
Right.
basis. Now, if you have a $200 electric bill, it'll probably take closer to a 10 kilowatt system
To do your whole.
to do your whole house,
Okay.
and we can easily accommodate that.
And what would it cost to put in a 10,000, or what you just said?
A 10,000 watt system at about $250 a watt installed, about $23,000 to $25,000 installed.
Okay.
So now you've locked in your whole house energy at that cost. At basically, well, if you take the tax credits with it and the TVA premium buyback, you're looking at about 5 cents a kilowatt for the electricity that you're purchasing, and you've locked that rate in for the next 40 years. TVAs traditionally raise their rates anywhere from 3 to 6% per year. You escalate your $100 a month electric bill this year, 20 years from now, it's going to be $150 a month. That rate continues to increase. So buying the solar in today's dollars, you've locked in that price for the next 40 years. So that would be the benefit of having solar in the house. You're buying you're your own little power station. You're not renting that power from TVA anymore. You're not subject to their rates or their availability.
And if you produce more than you need, they'll buy it from you. Is that right?
At this point, they do,
They
yes.
do, okay.
They are trying to phase this program out because they're losing money on it. They have more people putting solar in than they do have people paying the extra $4 or $5 a month on an electric bill to support the program. So that's what happens when the government tries to act as a corporation a lot of times. So I'm not really thrilled with it. I personally would wish that TVA would actually get out of the solar business, deregulate it, let homeowners decide how much electricity they want to produce. If they have excess, there's a federal law that requires a local utility to buy it back at least a wholesale rate. So if you do have excess, that federal law will trump any TVA mandated. But what also does is TVA, the 12-cent premium they pay us, it generates every kilowatt hour of electricity that we produce in the United States. Not only produces electricity, but it also produces a renewable energy credit. It's an actual carbon offset that you can have verified, and it's a tradable commodity. I can generate those credits in my business. I can take them down the street to another company that maybe is not producing green power, but they want to participate in green power. They can buy that credit from me and use that to show, hey, look, we have actually bought clean energy from a clean, renewable resource. Here's a certificate that we have to prove it. So my thoughts and hopes and dreams is that TVA will get out of the solar business, deregulate it, let homeowners, let business owners, let industry decide how much they want to invest in solar, build those energy credits and use them and let the market decide what that energy credit is worth. And a great example of that is what Volkswagen's doing in Chattanooga. They are not participating in any TVA program. All of the energy they're using is created and used on site. They also generate renewable energy credits and carbon credits, which can be converted into leads points. And I think he's going to touch on a little bit on the leads points tonight.
I really wasn't, but
Okay.
that is a LEEDS Platinum, a assembly facility.
Exactly, and to get that facility to a LEED standard. A LEED standard is a building standard here in the United States that says, hey, we're efficient, we're environmentally friendly, and here is a formula that we use to prove it, and we built it to this standard. Solar produces a lot of those LEED points for you. So the 9 megawatts that they're going to be building, it's only 20% of their actual consumption, but it also generates those renewable energy credits, and they can use those in-house to show that this facility, this manufacturing facility, is environmentally friendly, it's sustainable, and it comes from a renewable, verified source. And they're doing that all without TVA's involvement, and that's a $30 million investment. And I guarantee you, somebody at Volkswagen is not going to invest $30 million if there's not some kind of economic benefit and/or environmental benefit attached to it. So I know that if Volkswagen can do it, that I can promote it through my business to homeowners, individual homeowners, businesses, schools, those places, and I think they will benefit more from that type of program than anything the TVA could offer them at this point. So that's kind of my standing on my soapbox, preaching to the masses. So I would encourage you to take a good listen to these two gentlemen first, get the energy efficiency corrected, and then take a look at solar. Energy efficient first, power production second. You'll find that if you get your energy, and a lot of this is repetitive, if you get your consumption down, you don't have to produce as much. So, and that's kind of where I'm at. Anybody got any questions?
The developer that's doing that, 2 million, or however much it was.
30 million.
30 million.
Oh, no, you were talking about the guy that I'm working with? Yes, that's a $2 million project.
The array. He's gonna sell that energy to the homeowners?
He actually owns the homes. So he's built the homes, he's developed them, he owns them, and he rents them out.
Oh, rental.
So does that plant provide all of the electricity for all those homes?
It does indirectly. The way TVA's program is set up now is that we actually produce the green energy and we have to feed it directly to the grid. We can't consume it on site. But because we are powering that grid right there, it is indirectly feeding those houses.
Cool.
Have you already done this project, or is this?
We break ground Monday.
And it's in Chattanooga?
It's in the, if you, the last exit, going out of Cleveland into Ooltewah area, it's right in that area.
Okay.
And we'll have a big press
Oh, is
announcement.
it the one by the golf course, the honors course?
No.
That's not that one, okay.
But we'll make a big press announcement and everybody will have balloons and we'll toot our horn.
So they have to tie into the grid.
Yeah, the way TVA mandated is that we have to tie into the grid. They buy 100% of it. And the reason they do that is because that 12-cent premium is actually producing a renewable energy credit for them. So they've got to take all the power in. If they're using it on site, then they can't come back and say, oh, we generated a renewable energy credit, because the program, the Energy Smart program said, well, no, it was used right here in this house. So you either participate with TVA, get their 12-cent premium, they keep all of the renewable energy credits and pay you the 12 cents.
TVA gets the credit.
Exactly. TVA keeps the credits. So my philosophy is to get TVA out of the picture, let the homeowner decide how much solar they want to have, and let them utilize that credits to help offset that cost. Open up a free market, let them to be traded just like commodities, where, let's say like a school can't afford to buy solar, but they want to start that green initiative. They want to add on to it and gain some lead points. Homeowners like yourself, communities, could sell those renewable energy credits to that school, and that school could then use those renewable energy credits to show that, hey, we are a sustainable school, because we're buying actual green, sustainable energy. And that green energy certificate is a way that it is certified. And it's a one-time use. So you register it, you use it, it's good for a 10-year period, or 2-year period, excuse me, 2-year period. And that way they can verify the energy that we've used at this school, this facility for the last 2 years. We've got a certificate that says it's been used. That way it can't be traded and used over and duplicated on other projects. So energy efficiency first, and then we'll talk solar. So, any other questions? Did any of that make sense?
Yeah.
Yeah.
One other question, and I think the Volkswagen's choice kind of answers it, but the technology is mature, and
It has gotten, the technology has actually been around since about 1890, when the photovoltaic effect was actually discovered. Thomas Edison thought it was one of the greatest things in the world. I think he was actually quoted as saying, I hope it doesn't take 100 years for us to develop this wonderful technology. Guess what? It's taken us 100 years to develop this wonderful technology. But the efficiencies in the way the solar cells are made right now, there's some room improvement, but just the physics behind it isn't going to allow it to be 90% efficient.
the margin.
It is. It's just with the technology we have, with the silica crystals that we use, there's only so much we can use with them.
I like answering that question by saying that the modules themselves, the collectors, have a 25-year warranty, which, when you read the fine print, that says it's going to lose about 1% per year, but if indeed something does happen that's with the technology, and so I think that's just a powerful way of answering, is that there? The inverter, which is not a trivial piece of this, the part that converts the DC to the AC to then feed,
Right.
hasn't been dropping in price, but that is a little bit more vulnerable piece of equipment, of which warranties on that.
Yeah, let me touch on that exclusively. We have even the inverter technology is a little bit dated technology. There's only so much you can do with that current technology. That technology's been around for 60 years. We have moved into exclusively using in-phase microinverters. It's a totally different process. Those inverters are about 96.9% efficient, and they come with a full 25-year warranty.
Well, they do. These
So,
are back.
exactly, and that's where instead of having one big giant inverter that hangs on your house that everything feeds into, each individual panel has its own little tiny inverter. So it's not, it doesn't have to rely on its neighbor. When we use, typically in a traditional system, we would link them all together. And a good analogy would be like batteries in a flashlight. You get one bad one, the flashlight don't work. And you're sitting there trying to figure out which one's the bad one. Same thing in that string inverter technology. As they're linked together in series, if panel number 2 has some type of power drop, it affects all of the other panels in that array, so they will drop to meet that power. With the in-phase microinverter, because each inverter is inverting electricity at panel specific, then if we have a failure at panel number 2, it's not going to affect any of its neighbors. One of the good things that I like about the in-phase is that it also self-monitors itself. It can be accessed on the web at any time. It's a 24-hour self-monitoring service, and that's free with the product. It's for the monitoring is for lifetime. The product warranty is for 25 years. So at our company, we have made it the 25-year power output guarantee. They guarantee the panel will produce at least 80% of its rated power for 25 years. They guarantee that. Doesn't mean it's going to quit working in 25 years. They have a 40-year life expectancy. But what it means is that we can now guarantee that inverter is going to have the guaranteed life expectancy of that panel as well. So we've mated those together. So now I can confidently tell you that yes, that system, you're not going to have to change that inverter out for 25 years, and I'll guarantee you that 80% power for 25 years. That was a huge step for us, coming from string inverters. Like he alluded to, these string inverters, the typical technology that's been around for 80 years, they have a life expectancy of between 10 and 15 years. So you would have to calculate that into your projection of replacing that inverter at $10,000 or $8,000, whatever it costs, every 10 years. That adds on to the buyback time. So with the in-phase having a 25-year guarantee, we're not having to replace an inverter every 10 to 15 years. So our buyback is between 6 and 8 years, depending on your tax liability.
It's called in-phase.
In-phase, E-N-P-H-A-S-E. You can visit our website, is jbcsolar.com, and I've got some cards here I can give you guys. We've got some great videos on the in-phase system, how it works, with the solar panels that we use. So you can get yourself a little educated, or you can go right to in-phase site itself. But these things monitor themselves, and they upload data every 15 minutes to a central server. So you can get it tied into your smartphone. So if there's a problem with your solar array, you'll know which panel it is, how far it went down, what time it went down. And not only will you get an alert, but as us as the installer, it'll send us an alert. So if you're out of town at the beach or something and you don't know it, hey, we just go ahead and say, Ms. Johnson, panel 7's down. We're going to run out and take a look at it real quick. Okay, Tom, head on out there. 10 minutes, I got a guy on the roof. He's on the phone with in-phase. They can monitor this thing remotely because it communicates through the web. He's going to go through a little quick checklist with us. hey, is this wire loose? No, okay, all right, check this, check that, and within 5 minutes, we'll know if it's a panel failure or an inverter failure. Now, I'm gonna do a little selling here for Enphase. Also Enphase, because they're so confident in their product, and we've installed about 1,500 of these individual units, and we have a zero mortality and zero failure in the last 4 years. There's over 1 million of these on the market worldwide right now. But they're so confident in that product, and they're so accurate in their monitoring. If that inverter does fail, they know exactly when it's gone down. They'll pay the installer to take it off your roof, send it to them. They'll send you a new one. They're going to pay you for the energy that you lost while that inverter was down, because they know exactly when it went down, and they will know exactly when it came back up. Now, it might only be down for 3 or 4 days, and you might get a check for $2, but they're paying for that energy you lost. That's how confident they are in the product. So it's great. We like the Enphase product a lot.
I just want to make sure I understand. Did you say that, okay, a homeowner puts the solar system on their roof
Or on the ground.
or on the ground,
Sure.
wherever. They don't get to actually use that energy?
Not if you're participating in the TVA Generation Partnerships program.
Okay, but if you're not, that energy can actually
You can
generate.
consume that energy
you
on
can-
site.
Okay.
Absolutely. And you can actually start creating your own renewable energy credits. That's kind of where I envision and where I'm kind of pushing TVA, and I'm trying to open it. The renewable energy renewable energy credit in the state of Tennessee does not exist now. I'm going to make one.
What are how do you know if you're participating? Do you sign some kind of agreement
Yes,
with TVA?
when you would go to your local utility, we'll use Volunteer Electric as an example, that's a big one around here, a lot of people know them. You would go to them and say, hey, I want to participate in the TVA Generation Partnership program. I want to put a solar system on my house. And they will say, okay, well here's about an 8-page little document that's going to be a contract with us. And we're going to guarantee you that 12-cent premium for 10 years on top of whatever the retail rate is. Then the local utility is going to have a little interconnection agreement that you're going to sign as well that says, okay, you're hooking into our grid. We're giving you permission to do that. And they're also going to ask for a document from the installer. It's called it's a technical interconnection. Do you remember the name of that, Mr. Prophet?
No, that's your part.
This is one of my instructors that I was talking about when I went to the program. So I was hoping I was going to catch him off guard. I did, but I forget the name of it. But it's an application. Basically, it's the technical part of the application. The TVA wants to know where the money's going. Your local utility wants to make sure that it's safe and that the products that you are using are recognized by the National Electric Code and is UL listed for grid interactivity. What grid interactivity means, because you're producing power, sending it up to the grid. Transformers that hang on the side of the pole, they work in both directions. So only you're maybe pulling 240 volts off of it. When you're putting power back into it, it's coming back out at between 19,000 and 22,000 volts. So these inverters have to recognize if we have a storm and the power goes out, it has to, within 3 milliseconds, be able to recognize that the grid is not operating correctly and disconnect itself. The reason being is because as these linemen go out and they're putting those lines back on, they've got it shut off at their substations and their little disconnect areas, and they may think this whole street doesn't have any power on it. But if you're backfeeding 240 volts up through that 5, 10, or 15 kilowatt transformer, it's backfeeding that line 19,000, 22,000 volts. You can kill somebody. That's why it has to be listed by UL. And your local utility is going to want to see a paper with a technical line drawing on it explaining exactly what components are in the system, how large the system is there a visible lockable disconnect? Because what will happen is if we do have a storm and our power goes out, the utility company wants that lineman to know that he's going to have a map, and it's going to say, Ms. Johnson's house got a 10K solar system on it. They want him to be able to get out of his truck, walk over there, and pull that handle and disconnect you completely and be able to lock you out of it until they get those power lines restored to service. Once that happens, then you can turn your power system back on. But the inverter, you may not be home when that happens. So that inverter has to recognize it, and the frequency on the voltage on the line coming from the utility, if if it goes out of phase or drops or there's any problem, it has to automatically disconnect itself. So your utility's going on a little paper. It shows what type of inverter you're using, the model, the make, the manufacturer. Has it been listed by UL? Has it been listed by CEC, the California Electrical Commission, for grid interactivity? And there's a list of manufacturers and models that are acceptable. If you're not on that list, you can't use it, and that's a safety issue.
So if that should happen.
Yes.
And you get disconnected,
Right.
do you have power at your house?
No.
You don't? So
You do
you
not.
can't, there's no way for you to use the power.
Not when you participate in the generation
Right.
partnership programs, because we send all of the
All of
energy
it.
back to the line side of the utility.
When you're doing that, you've got 2 meters on your house. One's for your incoming power, and then one's for your outgoing from your solar array
That you're producing.
to the line.
So if you produce enough for your household and you never need any more than that, are you making money?
You can. And what we found is a lot of folks will take the backward approach. Instead of doing the efficiencies first, they'll get all excited about the solar. I have that effect on people. And they'll buy a solar system, but as soon as they get it and they start seeing that meter turn, then they start going through their house and they say, oh, you know, I can put a hot water blanket on that heater and I can turn it down 5 degrees. That's going to save me some more energy. That's going to make me some money. You know what? I'm going to go ahead and insulate all those windows. I'm going to go ahead and put a little bit of extra insulation in the roof or in the floors. And they start that process. It's kind of a backward process. I prefer the energy efficient first, then the solar. But what they'll see is that they're actually generating a small amount of profit off of it. Some of the larger arrays will actually generate quite a bit of profit of it. And that's part of the TVA problem, is that they're paying out more than is coming in. It's basically what's happening. And that's why.
When you have a solar array on your house, you think about it, you're producing electricity from it only during the daytime when the sun is on it.
Right.
So if you have a self-contained system where you're using all the power, you gotta have batteries to store the electricity for you to use it at nighttime. So what with the TVA Generation Partners Program, you're selling them power during the day at 20 cents a kilowatt.
Yeah,
And
it's about
you're-
21 cents a kilowatt. You're selling to them, but
You're
you're
selling
only
them
paying
at
10
10
cents.
and you're buying it back at 9 cents or the 12-cent differential. So you're selling it at more than you're buying it, so you're making money in essence. And if you use a lot less power than you
Then you increase
Then
that
you-
profit margin,
right,
which
you make.
shortens your buyback time. So there's a lot of people that do that.
Okay, do you have your crystal ball with you?
I do.
Okay, well then answer me, riddle me this, Batman.
Yes.
Okay, when the 25-year warranty is out.
Sure.
So 25 years from today,
Right.
do you expect, when we replace those in 25 years, do you expect the price of the panels, for instance, to have just gone a lot cheaper, a whole
You know,
lot cheaper?
and I can address that directly. A lot of people, and I see a lot of ratings in trade organizations, I can't wait till we get to $1 a watt installed solar. It's never gonna happen, and I'll tell you why. Some of the intrinsic values of the materials that are made in the solar, the aluminum, the copper, the silica, those are traded commodities on the open market. Those prices very rarely come down, unless it's just saturated. The cost of copper and aluminum is going to continually go up. The cost of labor to put those together is going to continually go up. We've seen a drop in solar panels here in the last year, which was directly related to Chinese manufacturers dumping them in the U.S. So it drove the prices down. For the U.S. companies to be competitive, they had to start lowering their prices. We've seen with some of the tariff sanctions that were put on the Chinese manufacturers, it's kind of stabilized the market. And we're actually, this month was the first month that I've seen that the prices actually came up by about a couple of cents. Realistic number for an installed cost per watt, let's say 25 years from now, because of inflation, our value of the dollar is going to decrease as as it always does, unless we go back to the gold standard or something. It's going to be pretty flat, about $2 a watt is where I see it bottoming out realistically over the next 25
So
years.
even if everybody goes up and gets on board and everybody adds solar, that's not gonna drive the price down very
Because
much,
it-
because of
exact-
the material.
Right,
the
glass
material
costs so much to make, aluminum costs so
Right.
much on it as a commodity, copper costs so much as a commodity, silica for these wafers now are an actual traded commodity. Labor cost, that's a fixed cost, once you get a large labor pool, even though China, God bless them, they're doing it for nothing. The American manufacturers, we have a minimum wage.
Right.
You know, some of those numbers just are not, it's pie in the sky to think you're gonna get $1 a watt installed unless there's some type of drastic change in the technology. that would bring that kind of, now thin films are kind of moving in that direction. They really haven't got to a point where I feel comfortable putting them on somebody's roof for 40 years. Just some of the field tests they've shown, just not quite there. We keep our fingers crossed and hope, but, you know, I don't buy green bananas.
Ooh, I do.
Well, today,
I don't like those brown ones.
today we
but-
can do it, and we can do it cost effectively, and I can do it just about as cost effectively as you can buy it from your local utility. Any other questions? All right, well, I'm done. Thank you for your attention.
I'll go next. I'm Scott Wright. I am an architect. I have a company that designs and can build solar houses or energy efficient houses for you. I've got a website set up that's called Energy Right Homes. The right spelled with a W for Scott, for Wright, W-R-I-G-H-T. And then also I have a spray foam insulation company. Just out of curiosity, is anyone in here looking to build a new house? Okay. Anybody looking to renovate? Okay. And everybody else is just thinking? Or what?
Just got finished renovating.
Just finished?
We're done with it.
Right now, if you build a new house and insulate it with spray foam insulation, which is what this is a sample of right here, you can look at downsizing your heat and air system 50%. So putting in half as much air conditioning system as a conventional fiberglass insulated house. So right off the bat, you've cut your power bill by 25%, because typically half of your power in the house goes to heating and cooling, half of your power bill. If you take the next step and go with all energy efficient appliances, LED lighting, you can cut your power usage even more, such that you could be using 25% as much power as your neighbor. By the way, he did gut the original house, so we were able to spray foam the walls of the original house and the roof and everything. Power company came out to check his meter because his power bill was less than it was before he did the renovation. So the spray foam insulation really works. Here in town, designed the house for my cousins, 4,700 square feet. Their average power bill is $125 a month. 4,700 square feet. So you can equate that back down if you've got a smaller house. One of the things as an architect, when I'm going in and designing a new house for somebody, you look at the shape of the house that they want, the orientation. Obviously, if you have a house that is long or L-shaped, something like that, think about how much roof area you have and how much solar heat gain you have on your roof. That makes you have a very inefficient perimeter, long perimeter of your house, a lot of exposure. The more compact you can make a house, the better it's going to be as far as energy efficiency. Obviously, if you want to put solar panels on the house, you're going to want to orient it properly where you have a nice big roof facing basically south. If you're doing a renovation and you want to put solar panels on it, you got to have a south-facing roof. I mean, it's extremely inefficient, and I've seen it too many times where homeowners will put solar panels on one roof that's facing southeast, and then they'll put some on another roof that's facing southwest, and they're getting what, maybe 50% efficiency out of each set of panels?
And what they're trying to do is,
Doesn't make sense.
when that happens, they actually have to double the amount of solar panels because they're only getting half the efficiency off of
Right.
each one.
So you can't just put solar panels on any house, and if you're renovating, there's only so much you can do in an existing house, depending on how much you want to spend, really. There is, one of the things about the spray foam insulation is that when we go in to do a house, you can see here that the spray foam typically is put in 2 inches thick in a wall and 3 inches on the roof. 3 inches of closed cell spray foam is equivalent to R60 fiberglass. One one thing that this does, you can see how well this is bonded to that wood. When you insulate with spray foam, it's like gluing your whole house together. Studies in Florida, University of Florida did that 3 inches of spray foam insulation will withstand a Category 4 hurricane. What we're doing with this is spraying it on the underside of the roof. So now your attic becomes an extension of your house, basically, of the conditioned space below. We've done typically an attic where the insulation is at the ceiling can hit 135 degrees in the summertime. Any of you go up there and stick the thermometer up there, you'll see that right now. Typically, we're seeing 85 degrees max up there. We had one client, one customer who was scientifically inclined, and he put thermocouples up there in his attic and monitored it over the summer. He said his attic hit 86 degrees one time for less than an hour. So the stuff really works. If you're doing a renovation and you insulate your roof with this, you're going to see about 25% drop in your power bill. The payback for insulating your roof is anywhere between 5 and 7 years. Typically, your roof, you're losing about 40% of your air conditioning through the roof in the summertime.
And what kind of a cost, what cost are we talking about?
$3 a square foot on the roof, $2 a square foot on the walls.
Now, when you say roof, you're talking about actually the roof, the rafters.
Correct,
between the
that's what
rafters.
I'm indicating by
Right,
holding this up like
that's what I
that.
thought, that's what I
This
thought, okay.
being a rafter and that being the sheathing on the roof deck. What we're doing with the spray foam insulation is encapsulating basically the attic and closing it off. The attic is no longer vented. The attic becomes an extension of the space below. As far as heat and air load, it's as if you had a cathedral ceiling in every room in your house. It's up there, but it's part of the overall space. The other thing we do with the spray foam insulation is that we spray it on the perimeter walls of the crawl space. So now your crawl space is also unvented.
But, question. Don't you have sockets in there that you have the air going through there?
What we do is, at the overhang, we close it off right there so that your soffit vent out here at the overhang is still there. It's just letting in a little bit of air right there in that overhang. But what we're doing with the spray foam insulation on new construction, you can see very easily how we go up the wall, up the roof, and back down. Okay.
So you don't have those things in your soffits at all?
Correct.
You don't need-
You don't vent the attic, and you don't vent the crawl space either.
I think Jeff had a question or comment.
I'm very familiar, and I was going to show some wonderful data, what you just said, temperature-wise. But a big question many times is, okay, I'm going to have you come in, my attic floor is already insulated. Your recommendation on what to do with that insulation is? And that's extremely important.
Why?
What you're doing when you have your other insulation at your ceiling line, okay? Now, you don't always have to pull it out, and there's a situation where you don't. Typically, if you've got ductwork in your attic, you're trying to blow 55-degree air through a duct that's sitting in a 135-degree attic in the summertime. Very inefficient. You've got a lot of heat going into that air, and so that air coming out your duct is not 55 degrees by the time it gets to your room, it's 75 degrees, so it's really not cooling very good. By insulating the roof line, you drop the temperature in your attic, now you're just blowing 55-degree air through a duct that's sitting in an 85-degree attic, so it's much more efficient. It makes your heat and air system more efficient that way, and that's part of what allows us, when we insulate a whole house, to downsize the heat and air system. Besides the fact that we've got less heat gain through the walls, roof, everywhere, it just makes the system more efficient.
But why would you have to take the insulation out if it's already there?
Well, what happens is you've got potentially, want a little bit of heat exchange between the two,
Oh,
okay? Otherwise, you've got stale air up here in your attic. You want some air movement up there. If you've got an old house with ducts up there in your attic, those ducts are probably wrapped with duct tape, which is probably 50% falling off. So you've got a lot of air leaks up there in your attic. And in that situation, you've got air movement in your attic. Right now, if your insulation is at the ceiling, you're cooling your attic with your ductwork, and all that cooling effect is being just going out the vents in your attic to the outdoors.
what if you don't have your ductwork in your attic?
If it's in your crawl space, that's part of why we insulate the walls of the crawl space and make it an enclosed crawl space. When your ductwork's down there, it's the same thing. If it's old ductwork, it's leaking to the crawl space, so you're losing part of your air conditioning capacity in what you're leaking into the crawl space. Now, what we typically do is we install a 10 mil vapor barrier on the ground, turn it up the perimeter wall, and then insulate the perimeter wall down to that so that we close that crawl space and keep out any moisture. That crawl space then becomes an extension of the living space above as well. You don't need any insulation at the floor then. Okay. Now, what we run into sometimes in houses is where the bathroom vent will be dumping air, moist air into the attic. You gotta be aware of that situation and make sure that all the vents are going to the exterior.
What I can add to that, what I have found is without the insulation, exactly the same type of thing. In the winter, no problem in the summer with conditions. But this time of year, I've got two houses that I'm consulting with right now where they did not pull that insulation out. And what you have is just very high humidity up there. Now, that can be overcome, and many codes will require you to actually provide supply and return vents, which are necessary if you're going to leave that insulation in there, but would not be if you removed it. And so this year has been extremely problematic with that issue in houses that have tried to say, well, a little bit's good, a little bit more is better, and that's not how this works.
In this area, do you use radiant barrier?
Not with this product.
Well, no, not with that product,
Right.
but do you use radiant barrier in your attics? I mean, is that a
can.
product?
You can. I mean, if you're insulating at your ceiling and you want to attach it to the underside, bottom of the rafters, you can. I guess studies have shown it lowers the temperature in your attic by 10 to 15 degrees.
It's not as advantageous. And by the way, what some people have done, unfortunately, is the radiant barriers on the underside of the plywood then come over with this. You've just totally knocked out the few cents that you paid for that radiant barrier on the
Right,
underside.
right. You wouldn't want to do both.
Yeah. It's really a either or.
The radiant barrier is not going to produce the heat in the attic as much as the insulation will.
Right.
I've taken the thermal gun when the sun is directly on the roof and stuck my head out the window and shot the temperature on the roof, 187 degrees on the asphalt shingle, come in directly under it and shoot the temperature of this, and it's 85 degrees. That happened to be in a house that was still under construction with the windows wide open because there was no heat and air system in it yet. We had just finished insulating the entire house. And so you have, in that case, almost 100-degree temperature differential across the insulation. One of the other great benefits of this is that you don't get condensation within the insulation because this is a solid material. A lot of houses where you see a cathedral ceiling and they'll have fiberglass bad insulation up there, and guess what? That dew point occurs inside that fiberglass bad insulation, so you get condensation forming in there and then mold growing in your fiberglass bad insulation, and then eventually you'll see the brown spots start to occur on your ceiling. questions?
I would like to just ask you just to see what your answer is. Sure. But a lot of times, first of all, but you know, what happens when the flashing or something fails on your new roof? And I realize that this is pretty rare, but when you do have a roof leak, you know, how do you answer with this issue, which
With
now
closed cell-
doesn't allow the water to go right through where the leak was?
Correct. With closed cell, there's two types of foam on the market, and some of you may be familiar with Isonine as a product name. There's a few other, that's open cell foam is soft like a sponge, okay? And just like a sponge, it'll hold water if it gets wet. This is a structural foam. This is what's used in boats for flotation, keep them from sinking. The closed cell foam is the only insulation approved by FEMA for use in the floodplain because it will not absorb water. When we spray this on the roof, you can see it's pretty well bonded all the way around. If you've got a penetration where a roofing nail comes out, now you've got a hole there where water can come in through the shingle. What's going to happen over time is that your decking will rot out right there, but it's not going to come through. I mean, I won't guarantee that it won't come through, but basically chances are that it's not going to come through. Eventually, you know, 10, 20 years down the road, when you replace your roof, you might feel a soft spot right there, and you have to cut out some of the plywood, or OSB in this case, and replace a section of it. And what you'll have to do is take a crowbar to get it off the foam.
Are you gonna talk about geothermal? Is somebody gonna talk about geothermal?
I can answer a few questions, or somebody else can.
That's fine, yeah.
If I get to it.
That's what I'm interested in.
What is geothermal?
Rough, Jeff.
What is geothermal?
Yes.
It's a pipe that is in the ground, either a well or a horizontal pipe around your yard, or that uses the heat sink and the heat source. So when you take the heat to heat your house, you're actually taking it out of the ground and putting it into your house in the winter, and you're using it to reject it in the summer. That's generally an advantage, particularly in the winter, compared to a heat pump that's trying to pull heat out of very cold air, whereas the ground is generally, most of the time, very cold, is warmer. So as a result, it works more efficient.
Basically, in this area, 5 feet down in the ground, the earth stays at 55 degrees year round. So you can put pipes down there in the ground and take advantage of that. In the summertime, it's cooler than what you want, and in the wintertime, it can be warmer than the outdoor air temperature. So you can use that temperature differential to draw heat off that water or whatever the fluid is that you're running through the pipes, and use that to heat or cool your house.
Super efficient. I think about 220 to 250% efficient on the geothermals.
If you look at, if you compare to SEER, the 13
Right.
is minimum you buy now, SEER would be, they use EER, not SER, SER would be 25.
Right. Basically what happens, 55-degree temperature sounds cold, but there's a certain amount of heat. Think of it this way, there's no such thing as cold. There's not. So that 55-degree temperature is constant year-round at a certain depth in the ground. So you can either, in the wintertime, take that heat that's in there, transfer it, and put it into your house. In the summertime, you can take that heat that's in your house, run it down to that 55, and disperse it into the ground. So you take the heat that's in your house in the summertime, you disperse it into the ground because it's at 55 degrees. Make sense?
Oh, I understand how it works.
Okay, I'm sorry. I thought you.
No, I basically understand how it works.
One of the things to keep in mind too with geothermal is that there's a size point where it makes a difference. If you have too small of a house, geothermal is not efficient enough for you. You've got to have a bigger load really to make it efficient. The smaller air conditioning units are really becoming much more efficient, and some of them are surpassing geothermal in efficiency levels. So So the technology is always changing, and they're kind of leapfrogging each other, so.
How big are we talking? I mean, how big does it have to be?
Typically
efficient?
about 5 tons, to make
I mean, how big does your house,
geothermally efficient.
how big does your house have to be? Isn't that what you're talking about, the size of the house?
Well, if you have a foamed house, 5 tons, it'd be a 5,000 square foot house.
Okay, I'm gonna show you a couple of houses that, one I had a geothermal system on, which was 1,200 square foot.
We have an old house and we've done everything we can think of. I mean, it's 65 years old and we've done everything we can think of to make it more efficient in terms of new windows and all that stuff.
My house is
It's
150
still-
years old. We have gone in and foamed the roof and the crawl space and cut our power bills in half. We have, at this point, no insulation in the walls. We just haven't gotten around to doing that yet. But we do have a pour foam. My house is got horsehair plaster on wood lath. And there's open cell foam that you can use inside an existing wall. But in our case, we have the sheathing boards with the cracks. So that open cell foam would go out, ooze out through those cracks and contact the brick and whip water in. And then we get moisture in on our walls. We have a new product on the market now that is a closed cell pour foam where we can actually go in and drill holes about 3 to 4 feet off the floor and another one near the ceiling and pour the foam down in there, and it's a closed cell foam that will expand in that cavity. And even if you've got a newer house that has some fiberglass insulation in it, the foam will actually just compress it out of the way and just push it aside.
I guess I just want to make a word of caution on this as well. I was at the Oak Ridge National Laboratory for a while and had tested about 500 different wall systems, and we would inject into cavities, and with the foam that we had at the time, that when we injected, yes, it did a fine job, but when we pulled the drywall out, it had shrunk. And now the specs say less than 1%. And that may be good enough, but if you think about, this is called drill and fill. You can go and do this with cellulose. You can do it with fiberglass, and yes, you can do it with this foam. You don't get as good a potential air tightness with cellulose or fiberglass, although it's not bad. And if I'm going to pay a premium for the foam, drilling and filling, I really want to have that air tightness, so that potential shrinkage is an issue that the manufacturers have said, we've taken care of that, but that's extremely important because that's an investment that you're making that you want to count on the benefit of the air tightness, and you want to make sure it stays there. On your house, just to answer that, you've tried everything to tighten your house. Have you had a blower door study done on the house, test? That is a very insightful. It's not that it's gonna drive you nuts, but what it'll do is potentially show you some huge gapping holes that you just didn't know about. Very.
What do I want?
It's called a blower.
You want the guy right behind you.
Blower.
It's called what it's going to do is it's going to pull a negative pressure on your house, and you're going to just walk around after you've done a few of these. You just walk with your hand, and you go, whoa, what's this? Oh, okay. Yeah, but you can do smoke pencils and things of that sort. But it's going to and then most importantly, it's going to give you a number that will tell you, kind of how you are compared to other houses. And I've done 10 of these. I tried to take and make like 50% more tight, and I've gone from like some of them as much as 25 air changes at this 50 Pascal, which is a certain negative pressure, and have gotten them down to the neighborhood of around 4, which is a huge improvement. But yet, I'm going to show you houses like this that are down in the 0.07 air changes. So when you say you can't get there with older houses,
Oh, I'm not saying we can't. I'm just
no, I had in my path of this thought I could get down that tight, and you can't, and I've yet to confirm that you can. It is very difficult as you get these older houses.
Scott does a blower door test on every house that he does foam with incredibly good numbers.
Okay.
It's the same sort of numbers we're talking about here, Chad.
Yeah, and in fact, you know, I'm gonna talk more about retrofit on Thursday than I was prepared to do here. But let me just say that there is one very nice house that was a 71-year-old, just clean box, 2-story, and we foamed and measured about 10 times, and actually started with, you could see the sky, and obviously you couldn't get a reading, but I kind of walked through the whole series, including the basement, of making it progressively more tight. And I really urge, with you having the tool, to do some of that, to kind of see where the biggest bang is. Not on the R value, but on the where that air tightness is. And that's been a very valuable insight to see where it really benefits the foam. Yes?
I have a question. You keep talking about air tightness. Isn't there a point that you have to stop because of cold, stale air? You've got to have some kind of air exchange in house?
And you do that in commercial buildings now. I mean,
I'm talking about a home
I know,
itself,
but think about a commercial
you do a lot
office
of cooking
building.
and other things in the house, and that air has to be exchanged somehow. Anyway.
Right. The straight up answer on this is, as you're pursuing this, is you can never make it too tight. You want to control everything that comes in and comes out of your house. So at some point, you want to have fresh air coming in, but the way to do it is mechanically. And then that can be done in a variety of different ways. But when you're doing a systematic tightening of a house, there is a procedure, and there's a heavily vetted standard called ASHRAE 62.2 that is out there, which has got all the epidemiological studies and tons and tons of people yelling and screaming at each other for years. Doctors, epidemiologists, the whole works, and have come to a value of what is the proper air change. And that is about 1/3 of an air change per hour. And that's what you should have. And you should have that on flat all the time. What happens with a lot of our houses is when we want it the most, when it's real windy and cold outside, that's when that air change is 6, 7, 8. And that's where you're really losing money. So it's a big misconception. The house doesn't have to breathe. You have to breathe. But you want to have that envelope absolutely airtight. And then at some point, and as you walk through this, you would like to have an energy recovery ventilator. And that is where I'm taking my stale air out and bringing fresh air in. And I've got numbers on one of these little systems that says that you can recover 70% of your exhaust heat from this small little.
So you actually recommend putting in the energy recovery air system also?
Well,
energy recovery system too.
It kind of, for new construction, it is absolutely the way to go.
But I'm talking about a 60, 70, 80-year-old house is not going to have that.
You can if you want to. You can add it on if you have new.
That's what I'm saying. You have to recommend.
Yeah,
you recommend things like that if you're going to seal a house that tight.
A house that old, you're never going to get it that tight.
And I'm here to say that I foolishly tried like a dozen times to try to get, and this number of like four air changes, 5, is the point where after a lot of chasing and rechasing and retesting is about as good as I could get. And this was a balloon constructed, home, and like I say, you just swear there can't be another place, but it's there, So it's, but I hear that this argument comes a lot, and we have many just on construction sites about the reason I'm doing a crummy job is it's got to be okay to let a little air in, and that's just a huge urban fallacy that we have in a lot of places. But there's no debate at people that have taken, and there's been millions of these houses that have been taken, and that is the philosophy. I mean, the little jingle is you make airtight, you ventilate right, and that's the, and it's not a debated principle that you want to follow.
I'm real cheap in a type Can I do one of these negative pressure tests myself? Is there a home way to do that?
Well, you know, yeah, I've had that you know, you can get a pretty good powerful fan, and you want to put it in your front door, back door, and as best you can, you want to try to seal up, and then you want to blow out. Now, you're not going to have the pressures and the measurements. You're not going to have,
Right.
although you could go get an anemometer and jerry-rig that. But if you could get yourself a pretty good, powerful fan,
You can get a window fan and put it in there and have it blowing the air out instead of in, and then walk around and kind of feel where air is leaking into the house. Get an idea.
But-
The typical blower door test is set up in a door and has the fan, but then the plastic sheet that covers the rest of the door.
Right.
So you're blowing the air out, and then you
It's not
walk
gonna
around
rain.
the house and you can feel wherever air is leaking in.
How big a cheapskate are you? They're not very
Yeah.
expensive to do a blower.
It's $150 or so for,
Okay.
And in general,
And
they
what
don't save
it-
that much money in a year, right?
yeah, what the blower door test is doing is, when it's blowing air out, it's the equivalent of a 20-mile-per-hour wind blowing over your house. So that's how you can walk around and really feel. It's like a winter storm.
Yeah.
I first had one of these. First time I set an eye on one of these was in 1980, and to this day, it is the single most valuable diagnostic that you could ever do on any house. I mean, if you're even, it just stands tall. And there's been all sorts of people that would love to try to figure out how to get rid of it. And I've come to the position where people kind of intuitively know. I mean, with the TVA evaluators, they know where 90% of it's likely to occur. But when you're chasing, when you have that expression, I've tried everything else, that is the best thing you can do, is to bring that, that somehow get that. In fact, if you haven't done all that, you're not going to get any kind of air. Your house is so leaky, you're not going to be able to see where the kind of, if you will, kind of less intuitive leaks are occurring.
Right.
That's
If you've
why
got
I would get some of these bigger things for you, pay someone professional to do it.
Right, if you've
Like,
got an
do my
old,
own,
real
it's
leaky
hard to-
house, you know it's leaky, there's no use in doing the blower door test. You gotta
Yeah.
address some of the major things first, and then you do the blower door test to track down the last 20% of
Which
the air
backs
leaks or
down.
something. Right.
But having noodled on this for a long, long time, there's so many simple things that people can do, and it's really stuff that if you brought even very low cost labor in to do some of this stuff, you could have knocked this thing out. And then that money that you want to set, that you just don't want to mess with, then you begin to really pay for the good stuff like the solar and things like that. We ready for you? Okay. Well, let me tell a little story here to start with. I have been blessed with the opportunity of coming down here next Thursday, and so the team here that's all in a row. I came in about a month ago, and we talked about a whole series of presentations. And tonight's was intended, at least my role of it, was more focused on new construction. And I had started heavy on this in 2002. In fact, the very first house that legally connected to TVA is in Loudoun County. It's a Habitat for Humanity. The second, the third, and the fourth. This was in 2002. It was a huge celebration. There were people that were saying, oh no, there goes the grid. We're all going to die. Nobody's going to be able to sell power in a reasonable manner. But it's been a wonderful thing, and it's been fun and exciting. But it went on to a house that in my research, well, I was at the Oak Ridge National Laboratory for 37 years. The focus of the program that I was on was called Building America, and its goal, and it was, I forget what administration was just coming in, but I was in a meeting, a very closed-door meeting. What do you think about this idea of, we've already been to the moon, so we're going to here develop zero-energy houses. What do you guys think? How long? Well, I'm sitting there thinking, yeah, I'll be able to do this to retirement. I mean, this is going to be an easy thing. But it's been a fantastic ride, and really an interesting focus. And a lot of businesses have built major plans around this concept. I left the Oak Ridge National Laboratory at the beginning of this year, and one of the things I've been asked by the Owens Corning Fiberglass company is to pull together a consortium because they have built this huge future business around the same idea. And the idea being, if we get enough insulation in there, the HVAC can be very small, the solar can be very small, but I wouldn't worry about that. Your roof is, you know, maybe not that set for that. So it's been a wonderful ride. Started with Habitat houses. I'm going to talk a lot about that. We went, and this was TVA that got us started on this. I went back to TVA and I said, hey, this is a big new thing. We don't want to be left behind here in Tennessee. TVA, to their amazement, said, let's go for it. A few of them said, you know, we do make our money here selling energy, you know, the idea of zero. Well, that's fine. It has enormous potential for peak savings. And the idea of these very tight houses, very efficient. If we lived in a perfect world, man, we wouldn't need that Watts bar too. We wouldn't need to spend $1 billion on Gallatin to prove it. But it's not that easy to get, you know, all 4.5 million of our houses to get together and be able to load them and disload them and stuff like that. So it's enormous potential. And after coming to all of this, and you know, oh yeah, we need more incentives. Oh, we need more politics. Oh, we need more baloney. I think what we need is a bunch of people that just say, hey, I have got this house, I got this car, I'm going to do the best thing I can with it, and forget about all, you know, who's going to help me do this. I mean, it's just the right thing to do, and there's a whole series of stuff that I'm just dying to get out, but it's not going to happen tonight. Most of it's going to be on next Thursday. But the idea of comfort of these buildings, you know, forget about all the other stuff. You know, the idea of having a more comfortable, productive, happy, you know, healthier house is one of those things that's just absolutely priceless. And we have a lot of support to show that. So what I've got here today is a kind of a start on kind of looking at the path of that I just feel really gifted to have been on, and of trying to get affordable zero energy houses, and so that's what I've prepared for you to kind of show, and the whole tale is going to take a while to get out, but I wanted to kind of give you this little outline. How far I get on this, I don't know. I want you to yell and scream, throw eggs, ask questions as we go here. But I had the opportunity, and not everybody does, and by the way, now that I don't have these big fat research budgets, I'm trying to do this on my own. And I'll tell you, to instrument these houses like I had instrumented, it's a $15,000 bill to get the data. And you gotta go, well, I'd rather take that and put it into solar collectors and insulation. But the idea is, and this, I just love this concept, one small house today, 100 million of them tomorrow. So there's so many doubting Thomases. There's so many people that just, for some reason, are in love with generating electrical power with coal that, you know, they think this is some evil conspiracy of some sort. And so let's get the numbers. Let's get the numbers for the bankers. Let's get the finance community. Show what an incredible thing this is. But believe me, I have been dosed in the reality of the true cost of trying to get some of this. And if you're just going to go sign checks and give, you know, one to the phone guy, one guy to the soul guy, well, you know, you ain't going to get there. You know, it has to be, everybody has to try to do what they can within their own house. And even when you get all this stuff, you just have to operate, you know, reasonable with the house to attain, you know, these very low energy bills. So then I want to talk about the envelope, and I had, you know, the kind of what I selected for the roofs, the walls, the foundations. I've kind of shown what's kind of evolved because I happen to have this ability to test 500 different wall systems. I did for new construction, and still absolutely like the idea of these structural insulated panels. I've built houses that are just incredibly airtight. And then you get that energy recovery ventilator, you recover 70%. The idea on geothermal, about 5 tons, you know, I put a geothermal system on a very small Habitat house, 2 tons. It killed it. It's, you know, very, very low, did a very good job. That same unit, about 4 years later, I put on a 4,000 square foot house. Never had a bit of backup electric to still maintain a dead 72 degrees 24/7 in that house. You know, so what you can do, houses that, that's a 7-ton or 5-ton house, you're now down about 2. And another one of my clients is Carrier Emerson, where they know the future is developing really efficient, smaller HVAC to feed this new housing market. And by the way, it's not a matter of if. This is coming, and the path of these very, very types of houses that we've been tinkering with, if you will, for the last 10 years. When it comes to equipment, this was somewhat innovative when I did this. In fact, I didn't go around bragging about it because I am an engineer and I didn't want the integrity of my profession tainted by a crazy idea. But this was, you know, when you do a house, you have a trench for the water, for the sewer, for the cable. You got all the, for the house itself, you open up a bigger footprint to put the footer drain around and such. Well, before closing it up, we put the geothermal loop, the horizontal loop in it. And this absolutely kicked butt. It did extremely well with the habitat. I then went to, in these houses, you can buy this house now. It just went on sale in Knoxville. It's about a $450,000 house. Took the same concept, put that with that geothermal system, integrated what we call a rain garden in their beautiful landscaped yard, and it's all now part of the heating and cooling system. Yes, absolutely. I love the concept of the frosting on the cake. After you've done a great job, again, if I was king, you now get awarded a solar system for your roof because you've really done great. I have tested a couple of different solar water heaters. In fact, Sustainable Futures, who is in the room here today, has been very a good partner on helping test this. I've tested a $2,300 kind of roll your own water heater and a $14,000 system. And when you talk about this, I've had no problems. I have had no boards go out, no collectors. Oh, we had a huge hailstorm come through where most of these experimental houses are. You know, it knocked out everybody's shingles. The solar collectors said, you know, what? That's all you got? You know, so they have been absolutely no problems. When it comes to solar water heater, and this is kind of an engineering 101, if you got a bunch of moving parts like a pump, you know, stuff seems to fail. And they've gone a long way, but I've had more trouble with the solar thermal than I have with the PV. They're just, you know, if it's in wrong, you're going to know that on day one. I've also created something called a zero energy core utility wall. When you have new construction, for those few of you that are thinking about this, what's happened, we've been blessed with a lot of very good architects, but they just listen to what you want. If you want a jacuzzi on this side of the house and the water heater wants to sit in the garage, you're waiting 5 minutes for hot water, well guess what? That can add up to a huge loss of hot water and energy and water while it waits around. The idea of, we always used to do this. You concentrate all this so the water heater and the needs are all lined up. And then what I've done with this is taken what's called a gravity feed heat exchanger, and that is where you take waste heat coming down right below your shower, and then your cold water from the street, which comes in the winter about 42 degrees, gets preheated before it goes to the water heater, saving about 15 degrees of energy that you don't have to put into that water heater. And it just kind of concentrates the waste heat where you could possibly use it for other purposes in the house. When it comes to the heating, ventilating, and air conditioning, and I don't want to get too out there on this, but there's this very straightforward, simple calculation for sizing that heating and air conditioning system and for sizing the ducts. It is amazing when you do these fairly simple calculations how incredibly well balanced, the idea of hot spots and cold spots, this just absolutely goes away. And like I say, I surprised, manufacturers of this said this, and I just guess I didn't believe it, but these units, when they're put in correctly, and what you want to have, more or less, is less of this heating and air conditioning and more of this fresh air stuff. And what you do is you pull your air out of your kitchens, your bathrooms, where the wet spots are in your room, send it to the outside, bring the fresh air in, squeeze all the heat out, sometimes even the moisture in the winter, and then put it into the bedrooms, usually behind a bedroom door or someplace like that. And you know, it's just a delightful high indoor air quality when that occurs. So now that I've left the research world, and boy, I didn't know how good those government jobs are, man. You know, I mean, you guys that have them, it's cushy. It's cushy. When you get out and you gotta try to get something going, so this is what I want to do. I've taken all of this, and I want to. And Beth Eason, a nice, good Eason architect down in Knoxville, that's her sketch. You know, we put this thing together, and some people would say, hey, I recognize that. That's a Habitat house with a couple of fancy details. And we could talk about a lot of different things, but it's a formula that I'm going to cut to it. I can do this for $70 a square foot, which is comparable to conventional construction. And I'm going to tell you the trick. The trick is if you can really take full advantage of a walkout below grade space. And if you can really make that high quality space, you can get your square footage down really, really well. And if this is south side, you got great daylight, you leave a little coming here, you can do a lot of stuff. We all know you can build a zero energy house, you can build an affordable house. The Holy Grail, and this is the mantra for all of us, and I think we all should be experimentalists on trying to attain how we can do, bring that together to truly do affordable zero energy houses. And there's interesting ways, and I'm going to, before I even get to this, I'm going to tell you that between the Habitat house and this 4,000 square foot was a series of houses, again, bless TVA's heart, they're called Campbell Creek Research Houses. They gave me one house. They gave me a builder. One day the builder gave me his construction crew. I more or less, day to day, put together a house that, yes, it cost $32,000 more, had 2.5 kW solar, had a wonderful sustainable future, 14K thermal water heater. That take out my credits, etc. That was an additional cost to this house of about $225,000 house. On top of that, another $32,000. And it's easier to do today if I can go get a mortgage at 3%, which some of you can. But I used only 6%. And what I found out on what we call a cash flow. Every month I got to pay the mortgage. Every month I got to pay, my TVA. That after a year, from the first year, if I were to bury that $32,000 into the mortgage, I had $70 in my pocket. So and I don't think I'm supporting you in the sense that this is here today. This is not something that is really expensive. Now, it was well thought out, it was well planned, it was incredibly efficient. It did have an energy recovery ventilator in it. So it had all the goodies, Got everything, and including solar on the roof. Life is good. And so anyway, I am committed to providing some material that I want to make sure, Tracy, that everybody here, that we get their name, and the whole piece of work on this is right here. So, we talk about it, on the stuff on Thursday as well, but that, how we got there, pictures, details, the whole shoot match is embedded in that. Okay, so what is a affordable zero energy home? It produces annually on site renewable energy equal to the energy requirements. Now this is, and I'm going to tell you that this house didn't truly get that low, but for the time felt that this, and I think I hit it pretty close, $70. If I would have put a bigger system on it, I may have lost my $70 and had to pay each year for the, more of that leftover that I still had to buy. But I'm going to show you some numbers. Just incredibly, there's months where I got $25. In the winter, the worst situation was about like 60. for everything, not just heating, cooling, all the appliances, the whole shoot match. Provide a standard of energy services equal so that we, and again, I say energy conscious, but this isn't anything special. This is just people, turning lights off and closing the door in the winter and stuff like that. On Thursday, one of the biggest things that I think we all get hung up on is, well, what's the payback? I'm only going to be in this house for 7 years. The world's changing. The market is going to reflect, and there's study after study after study that keeps happening to show, it's in my engineering economics class, it was called a salvage value. If I go and buy a really cool foam system, nice solar system, I don't have to live there for 7 years and have a simple payback. If we can get a rating on our house, or at least part of the overall talk of business that shows that the home energy ranking, if you will, is a very good number, that equates to a monetary value upon sale of that house. I'm not going to, and by the way, TVA right now is working on it. Okay. DOE's got a variety. It doesn't really matter what this ranking is, and this is why I say this. For a while, I was walking around the country quoting this wonderful study in Seattle. Right in the middle of the building recession, these houses that had the label were selling for $30,000 to $40,000 more, and were selling 3 to 6 months faster than the exact same house, supposedly, next door that didn't have the label. Nobody's even checking what it was, it just had a label associated with it, which generally means a third party, somebody did this. Well, this study that just came out from Berkeley last month, now talking 1.7 million houses, 4,000 of them had a label. A HERS index, 100 to 0. 0 is a zero energy. A good house, maybe 75, something like that. When you had something, this study showed that in California, the average new house, heaven forbid, sells for $400,000. Ones with labels sold for, on average, $34,000 more. When people looked at the added stuff that went into that house, that was like a 48-year simple payback. Whoa, why did people pay all that? What that shows is that the market is already beyond this. It's not just dollars and cents, it's people living in a house that they feel good about. And oh, by the way, that differential is bigger if there were Priuses in the driveway. So people are already, kind of, predisposed, at least some, towards, just wanting to take care of this. So when we talk about affordable, here's the hook. Added first cost, 30-year mortgage payment at 5% offset, was offset by the energy cost savings. So there's a whole series that we can walk through, and I'm going to spare you on this, but this is kind of the graphic display. This is like average cost of mortgage plus, well, this is all energy here, and then as time goes on, this drops, and you're working yourself down to zero energy and more mortgage. And what we talk about is a neutral cash flow. So what I told you when I said that added 32, that ended up right in here. So in other words, you're still putting out the same amount of money, you're more or less sending more to the bank, less to the utility. Which right now, why not do that? The interests are very, very, very low, and utilities are tending to continue to go up. So there's a whole kind of walkthrough on this, and I'm gonna jump over it, but it's a really nice way of kind of looking at the economics. This is the subdivision, the Habitat subdivision, where I'm going to talk about a variety of these houses. And this was, I can't tell you what a great combination of being able to experiment with Habitat with Humanity houses, and I got to know all these kids in the neighborhood and use their house for science experiments, and it just goes on and on about great stuff. They're all built with SIPs. This is Skyla Harrison. And she came there in 2002, very, very proud that this took place. All these have about 2 to 2.5, so not by any means enough to take care of everything. Here it is. This is a historic structure. This is the very first house that was connected to the Green Power Generation Partner house. And ended up getting credits of about $2 a day. And at the time, this was a surprise to me, that this was about $1 a day after that $2 was paid down. The average in the neighborhood is about $4 a day.
So Jeff, does that mean $30 a month utility bill, $1 a day?
That's right. That's exactly right. That's exactly right. And I'm going to jump a little ahead of this, but I mean, I was able to work that down to 48 cents. For again.
Excuse my ignorance, but I don't know what a SIPS is.
I'm sorry.
Oh, that's what it says right there.
I'm sorry. Yeah.
Sorry. Okay.
It's a structural insulated panel, and kind of, I can steal this prop. Instead of spray foam in it, it's got a piece of foam that they start with, and they laminate orientated strand board on one side and on the other, and it's a structural.
So they do that instead of putting in studs and.
That's right.
Okay.
But there really are still a few studs in there where I need them structurally, but I've counted the number of studs. I mean, it ends up being like about 8% in a pretty big, complicated house compared to when you add up all the studs as far as area, it can be as high as 30% when you have a lot of things going on. And that's all thermal shorts. Scott stuff's doing really good here, but not so good right here. And this is you know, if 30% is wood, you know, this ain't gonna get it. You know, so when you get to that SIP, you eliminate a lot of those what we call thermal shorts. Not for retrofit, for new construction. However, there's something called a nail base that I was hoping to experiment in with a house that's in Knoxville, where we're going to tear the siding off and put the nail base, which is only OSB on one side. Lots of impressive stories as far as very, very low energy bills that these very needy families were talking about. Worked with General Electric Corporation. They make heat pump water heaters. Actually, this is a predecessor to that. But again, this was something that, I guess not everybody could do this, but it was not that complicated. Where there's a series of motorized dampers. And by the way, there's people now talking, and this was done back in 2003, actually talking about mandating. If you're going to install one of these, you kind of have to do it like this. and of course, the manufacturers of these heat pumps, they don't want to do that. They'd like to just sell it everywhere, but because of the potential here, and I'm going to just explain this, you know, in the summertime, we're taking the heat from behind the refrigerator and using that because this is going to operate more efficiently because I need heat in there. So if it's warmer around my water heater, I get this to be operating a little more efficient. And then what comes off of this after I take the heat and put it in here, it's cool. So why not blow it back on the person in the kitchen doing the dishes, you know, who really needs some cooling anyway. So it's a great deal. But in the winter, that's fine. I don't need to do that. But in the winter, I can pull it from the crawl space. And if I got that crawl space designed right, I've got, this is kind of heated, not quite as nice as it would be if I was deeper in the ground, but it's tempered down below my crawl space. It's not, it's insulated, so it's not vented. So I'm taking a little bit better than from the outside, and that's why I call it the poor man's geothermal system. And then I use that to take the heat out, and then it doesn't have to work as hard. And I don't have to worry about the issue of, you know, really freezing the inside of the space if I have to have this sitting in a closet. It makes a great wine cellar, but it may cause a cold spot where I get a lot of condensation in my house. So you can't even put this in some locations when you don't connect it like this. So we did all sorts of fun stuff like that. I'm just kind of walking through the whole series of these houses. This is the house, 48 cents a day, 47 cents. Walls went in 5 hours, roof 3, 1 day to do the whole solar system. I'm sure you guys could have done a lot faster than
Half a
this.
day.
Half day, half day. Yeah, all right, this is, yeah. By the way, this is metal simulated roof, so believe me, I did whole structural analysis on the fastening. That was a little bit more complicated, but
What did you say the roof was?
it is a real cool. It's metal, but it looks like tile. It looks like you're in Italy or something like that, or yeah. Very, 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 very nice. This is the most ridiculous, stupid joke, but you guys try not to laugh. I'm going to experiment. Try not to laugh at this. Okay. All right. Nobody laugh. This is a joke, but nobody laugh. Okay. This is a single mother that lived in this house that had 2 children. The North City electric guy that hooked it up, his truck was out front one night. And just like the little story you told about the bill was so low, the utility came in to check late at night. And then when I got there early in the morning, he's still checking. Well, I want to tell you that electrician is now happily married to that single woman. I told you not to laugh! See, I told you. But it's so stupid. And so anyway, so we made nice progress on getting, we didn't get to 0. And actually, with today's exchange, it is 12 cents. These are numbers with the earlier version of this. We could get to 0 cost with these scenarios. I really should work this with today's cost. This was when the, I didn't want to go back, it doesn't matter, but it was before the sweet deal that we have now from TPA. Okay, geothermal. Kind of cartoon-wise, kind of showing how we, if you're going to put this, there's no flat spots left in Tennessee, so you're going to use your excavation. But before you backfill, let's go ahead and put these horizontal loops. And oh, by the way, this is how I kind of came to, everybody wonders, well, what is the best wall system? Well, I had a $2 million large-scale climate simulator to answer that question. And I put, like I say, 500 different systems in. I tested conventional frame, 1 window, 1 door. Yeah, okay, why is this foam stuff so good? Well, this is what happens usually with insulation. They compact it so the air leaks from here, works itself to the spaces, not with this good, bright foam stuff. But this is how you get with that. And so I was able to forget air leakage, just talk thermal. And then I kept it the same temperature, built the same house with SIPs. You can, sealing it is important. Then, I have to show graphs. Was able to, this black was real house, black was real stick house, red was Jeff's little dollhouse that he tested in this expensive. So I hit this pretty good. So I captured reality. And then the stick one way down here. For you mathy people, notice this exponential, this is a lot lower right down here. Sorry for I'm in an astute academy of science. I shouldn't belittle these things, I apologize. But the thing I really like about, and I think the answer is with the spray foam would be the same thing, is that before drywall, I can do my blower door, and then it gets to be real easy to go to the inside walls and seal them up. Whereas if the drywall was already on and I was counting on that for my air barrier, now I got to go down in the crawl space, fight the skunks, the mold, the mildew, the puddles that are still there, and oh yeah, here's where the leak is. You can do it all nice and clean from the outside. And something like this is going to happen for users that don't know this. There's the International Energy Conservation Code, of which 2006 is what's here in Tennessee, but 2012 is already on the, signed, sealed, approved, coming our way, mandates that blower door check before occupancy is allowed. Must be below 3 air changes at 50 Pascal. When the builders get to this first house, their heads are going to rip off. And that's why, having, some kind of process that makes sure these air tightnesses are done. This is the second curve here showing that when I built the SIP house, I wasn't too far off. So I kind of learned this, and this stays that way. Here's some of the numbers now. This was as good as I could do with stick construction and these are hard numbers from a bunch of houses that were in that neighborhood, and these were the SIP houses. And again, I've now been down to I think it's 0.07 the air tightness. So this is the construction of that house. Notice the exterior insulation on the outside. You can't do this with retrofit, but man, new construction, this has got to be, should be, it just is, this is the detail. You get it on the outside, you make sure Mr. Termite can't crawl here, up and chew on your wood. But now I have this thermal mass on the inside, beautiful, keeps you nice and comfortable. And if indeed the utilities ever get around to time of day ratings, where they say, I'm now going to charge you, instead of 9 cents, I'm going to charge you $1, like they're already doing in California. You're going to be able to turn that air conditioner off, and because you got this nice mass, you're sitting there just chilling. You're enjoying yourself. Everybody else is, oh man, I got to give me some of that 90-cent juice. But this is the way to do it. And also, moisture-wise, you just avoid all the concerns that you ever would have as far as risk on moisture management, because you've now pushed that danger condensing plane out here as opposed to near your nose on the inside. For those of you that can stand it, I've got a whole session coming on Thursday, and this is a really good workshop on foundations, on how to deal properly with insulating and moisture management for both new and existing construction. Drainage of the site, very, very important. There's an electronic handbook now available. It's already on the internet, which was one of the last deeds I did before getting thrown out of the Oak Ridge National Laboratory. We want to keep inside separate from outside. And that's what we did in this particular house, so that we don't allow water to go from here to the inside through our drainage system. But that's not used to be the practice, but today that's the way you really want to do it to build a good foundation. And oh, by the way, when I decided which is the best insulation system, I built something about, I guess now it's about 25 years, and actually put specimens and put heat flow transducers and thermocouples in the wall to kind of see what was good, what wasn't. And then about 15 years later, dug it up and pulled it out and made measurements. And so here's the numbers I had back in 1991, 92, and then when I pulled it out, I had, captured, well, did it really remain a good insulator? Did termites eat it? Was it full of moisture? Did it just lose its performance? So this is, XPS stands for the blue stuff, the extruded polystyrene. Now it's also pink stuff, but it's more closed cell. It's not the white styrofoam. It's not sprayed polyurethane. But that's the difference that we got. And I would conclude with this that I didn't want to see this kind of falling off after that amount of time. Was wet, so I dried it out. I'm apologizing, I'm jumping a little fast on this. But then I did the same thing with fiberglass. There you can see I didn't have that loss. So why do I like the pink stuff instead of the blue stuff? Well, this was pretty powerful to me. Rim joist, real critical, and good, and the idea of the foam takes care of that. With this system, I get not only insulation, I get good drainage system. This is just showing the continued assembly. We talked a little bit, somebody mentioned reflectivity. Well, you can buy these cool coats of paint. And I have put this on this house. I did it one way here and another way there, and then went and collected a bunch of measurements. And I'm going to going to spare the conclusion here. But what I'm going to tell you is that, you remember I said mass was important? Well, what that coating did was keep that mass, when I insulate on the outside, working for me all year long. Whereas if I didn't keep that sun from penetrating it after a while, then it wouldn't work for me because it was above my comfort temperature in the inside of the house. I apologize for doing this, but what it said was, I kept thinking, well, this ain't going to do that much if you got a bunch of R value already there. But what it did show is that I maintained this nice thermal inertia in my house, and if indeed this time of day electric meter ever comes to reality, this is a nice combination of stuff.
What'd you put on the outside of the foam? You just painted it direct?
That happens to be what they call the thermal mass system, which is concrete, foam, concrete. And the outside was made like this in North Carolina, and it kind of had a stucco look to it. So that outside surface is what you actually saw, and then that was painted whatever color you wanted. Slick system, a little on the expensive side. I was hoping the construction supervisor from Habitat was going to be here, but not, right, John? The biggest thing that you can do for sure existing, for new orders, is try to get the ducts inside the conditioned space. And this is kind of like the classic study. This is like Edison when he explained photovoltaic phenomena. This is the definitive study that showed hard measurements, the powerful benefits of getting those ducts inside the conditioned space. I mean, we all talk about this, but where do the real numbers come from? Well, this was one of the studies. So this is showing, and with the SIP construction, with that ceiling, or with this in the attic, you get this easy. You get the ducts inside the conditioned space. And here, we did it, kind of, this is where the duct system has to be. And you go, well, wait, whoa. I want my supply ducts going in these cold windows. Yesterday's stuff, man, yesterday's stuff. You can blow from here. We got perfect comfort right here. So when you did that manual, that right sizing of the HVAC, these issues are we continue to do ducts that are all the way over here and all the way over there. Nonsense. When you got a good envelope, airtight, rightly insulated, you can shoot from the center of the house. Wonderful comfort. This is the two houses that we played games in. The games we played were, let's make a measurement of the ducts upside in the attic and then inside. So I'm going to show a series of shots. We didn't worry because this was Habitat and we rented these houses. It's not a new way of doing your decor in your kitchen. We didn't care, So, but it's clearly inside, clearly up. And then, again, a bunch of plots. And what we found was this was when it was up in the attic. This is when it was inside. This is all energy savings. And what did energy savings do? Amounted to 35%. Heating and cooling. So when we compare houses, we want to calibrate our models and then compare. We saved a ton on cooling. We saved a bunch on heating, a bunch on water. What is now not as common, but this was all 100% incandescence going to 100% compact fluorescence, and now you can even knock that further by LEDs. But I want to show this. We assumed the same kind of internal everything else. We didn't take advantage of people behaving any differently. So that's important to show. And when we talk about these home energy indexes, a lot of people say, well, that doesn't make any sense because you're going to live in a lot more prudently than you are. Well, that's taken out. It's called an asset rating. So when they do this rating, they take out the differences between people. It's only what's in the house or not in the house. So I am an enormous proponent of getting something going on this labeling, and it would just make everybody's life so much easier if the market reflected the extra effort of getting those good things in these homes. So that's clearly done in these houses. Another good place is when you're building is to get these between floors. Having said that, all right, I'm an HVAC guy. All right, I'm going to take these little sections and I'm going to put them up here, and somewhere there's a chase in these trusses. Well, that's not what you want to do. You want to be smart enough to sequence so that you make your great big long central trunk, and then before you put the siding on the house, you run it and set that whole thing in there. With that, you got it all buried. Now this is good, high quality space. I'm not got this header that I bump my head on. You know, it's a nice way to get into the house. That's just a picture showing very important single central return. Doing a fine job. Somewhat, beating the dead horse. But when we get into existing houses, we all see places where they've used chases for return ducts particularly. It's absolutely deadly as far as then sucking out of the attic, sucking out of the crawl space. You really want to have good hard pipes that connect every return and every supply. You don't want to take advantage, because when that drywall gets attached, little, wood shrinks differently, and if it's not sealed properly, you got air that's going in there causing imbalances and all sorts of other nonsense.
Jeff, the code is addressing that too, isn't it?
Today, this is, in our larger metropolitan areas, these are inspected and checked, which means Chattanooga. I don't know if it means that here.
Well, the code is actually, it's part of the code now. Enforcement of the code and the code are can be two different things.
Yeah, but I do know in the Knoxville area, this is now inspected. There are, as of about 2 years. Is there a dedicated energy inspection in the Cleveland?
There's mechanical inspection. Yes. Mechanical inspection, city and county. They're moving toward getting these ducts better, but that's a long, it's a long, hard process to get an air guy to go from what Granddad told him to what he really needs to be doing.
Yeah. I mean, this is, I stopped telling jokes about this a long time ago, and then as I started to get into these houses, it's just, and then I've got a son-in-law that gets into, he's a TVA, a CSG or TVA evaluator, and he shares with me what he sees in incredibly intelligent people's houses, how they're killing themselves, with stuff that's right there in front of them, and I guess that's, to me, that $50 is worth the peace of mind of having these guys come in and say, oh, yeah, here it is again, the duct that's connected to the attic. What is that? So what? Well, so what? It's sucking cancer fibers down into your house and into your lungs, Geez, you ought to patch that up. Forget about the energy savings. All right, so ask about geothermal. What is geothermal? Instead of, there's the sewer pipe. Instead of just filling that back in, let's take that geothermal loop. It's called common trenching. It is every day done in Europe, all over the place. And so let's put that, make it a little bit deeper. And oh, by the way, okay, here we go again. All right, you failed the first test. This one, don't laugh. Do not laugh at this, okay? Everybody brace themselves. Do not laugh. Okay, sewer pipe coming out of here. So it's a very cold day, but that water that I just flushed with is now coming out of my house very near where this area is. I'm trying to get some heat out of here, right? Because I'm trying to heat my house. It's in winter. I just flushed. Well, now this nice warm water comes real close to the pipe. So that's why this is, brace yourself. So that's why this is called the hot shit part of the system. All right, a couple you didn't. All right, this is just the layout, and when people talk about temperatures, 50 at 5 feet, it's 55 degrees. Well, I've measured these temperatures since 1982. These are temperatures that are surrounding the pipe, and what happens, particularly in the summer, if you don't size everything correctly, and again, this is a very small system, but as I'm taking heat out of my house and dumping it all summer, around this time of year, we get what we call hot loops, which means if it gets It's no longer 55 because I've been throwing heat in there all summer. And this summer I threw a lot in there. What is happening is that temperature, when it comes back, is actually up around 90 degrees. That soil immediately around that pipe could be, and so the efficiency does fall off as the season goes on. And so you kind of got to be aware of that to have these sized right. But when you do it, you said, well, oh man, let a couple holes in my house so it breathes. Well, no, if you take care of all this stuff, now with great confidence you could size these things correctly and such that you don't have, you see, a geothermal system in the winter, if that soil gets too cold, you still got the resistance heat. In the summer, if you get that hot soil, some people will even turn their irrigation system on to cool the soil around their geothermal pipes that are in the horizon. That's not, nobody's making any good sustainable moves there. So it all kind of has to come together.
Explain that to everybody about the geothermal. That's one continuous loop of pipe all the way around.
There's one pipe that comes in, one pipe that goes out. And there's a header here. You saw there was actually 6 pipes. Well, there are 3 loops that goes that whole way. And again, the only piece of dirt that I actually had to cut was this right here. Everything else was open to me. And this can be an expensive proposition if I got to go and do this separately. In fact, a common yard, a neighbor in a typical subdivision doesn't have enough room to go off away from all these utilities. So that's the beauty of this integration. Thank you. All right, here we go. So here is more numbers than, I mean, this is what, they paid me huge sums of money to do this kind of stuff. I mean, I sat around and watched a hole, for 3 years, what the temperature was, but very, very valuable, very, very, very valuable stuff. So this is a cyclical behavior. So this is in the winter time, you're here throughout the summer, it's getting pretty warm, and you see, notice this can get scary. This loop is telling me it's 100 degrees. And this was a really, really hot summer. And if this keeps going, my career's done. But what this confirmed is I reached what we call dynamic steady state and ended up working absolutely just beautifully. And this kind of shows kind of those temperatures. And I think I'm going to have to kind of stop with this part. But when we talk about, this is somewhat theoretical, but when we talk about a vertical loop, I'm going to stop with this one. We talk about going like an oil rig and going, we can do this nice and flat, 55 dead on, if that's what we do. But if we're at that various depth, and here's the 5 foot, it does vary some. And so in the winter, it's really less than that. It's around 40. This is kind of our good point. This is going to vary depending on the climate. And then air temperature, you can see. And if I'm trying to do with a heat pump, pull heat out here, I'm going to work a lot harder than I have to if I'm at my 5 foot level. And in the summer, it reverses. The soil stays cooler, so I don't have to dump heating into this cold, hot spot. So with that, I think our time is up. I better cut it right here, and I'm not sure if there's a chance for a question or two.
Are you going to seal up your house? Are you going to leave those holes in your house, or are you going to seal those holes up? Maybe, maybe not. When we do a blower door test, so if you think about it, we go around and look, and we find air leaking out of switches, receptacles, down along baseboards, coming out of the attic. You want to put your nose down there and breathe that air? No. So we want to seal up those holes and bring in good clean air.
How many of you have you done renovation where you've taken sheetrock off the wall and you look at the insulation in there and it's gray or black? And that's air that's leaked in and is bringing in dust through your walls into your house.
Insulation's filtered for a while.
Yeah.
Until it got dirty.
Yeah. Do you want your insulation to filter the air you breathe? Or do you want your heat and air system filter to clean that air?
Well, I just want to give a major sales pitch for those of you that can make this. Although it's going to be archived in some fashion, and we hope that some good things are going to be done with this. But and there is a flyer that's now available that I assume if everybody leaves their address, they can be sent. But on Friday, the subjects that are going to be covered, starting out, is going to be a home energy rating. Could this increase the future appraisal value of your house? We're going to hit that real hard. From 9:15 to 10:45, getting your house on the path to affordable net zero. I've got 10 houses that I tried systematically to get very, very tight, and I've got all the bulletable on that. Is your home's foundation costing you money? Whole series of details, discussion on what to do with that troubling basement or crawl space, and gonna show you where you can get, and you can take these details and actually hand them to a contractor or your builder. In the afternoon, what energy solutions are blowing in the wind? I don't know if you guys know this. 37% of the capacity that this country added, electrical capacity last year, was wind. 37. What about nuclear? What about coal? What about gas? I thought gas was really cheap. 37. You know, this is solar basics. You need to come back and help me on this one. Solar basics to solar power your house or shower you with sunshine. That's 2 to 3. And then who will win the race to fuel the car of the future? Right now, big debate. Oh, we got all this cheap natural gas. Why don't we drive our cars with natural gas? You know, hey, yeah, but instead of this oil, $2 a gallon, $2 a barrel to get it out of Saudi Arabia. No, let's take it. You know, since we got all this, and a lot of people thinking, yeah, man, I'm tired of this $5 a gallon gas. Not so fast. I mean, these are some short-term solutions. So we're going to kind of debate that. So anyway, that's just a.
That's next Wednesday?
That is next Thursday.
Wednesday.
It says Wednesday at 12.
Well,
I'm going to be here on Thursday. It is next Wednesday.
Are you buying lunch?
I think
we
lunch.
will let the grant buy lunch on that day.
He's buying on
Well, no, I don't want that
Thursday.
exposed. I'd rather than think that I did.
But we will have lunch provided on Wednesday.
On Wednesday.
At 12. And if you would like a copy of the listing and didn't get one earlier, I have those, as well as a brochure about some efforts going on here on our campus. Also on the 13th, we have a panel from 10 a.m. until 12 noon, Simple Steps to Living a Greener Life. And it's going to be right here in the same building, so the same as the workshops on the 12th. And then on the 21st, we have Doug Bry, who some of you might listen to on your radios. He has a Home Remedies live show, and he's going to actually be here live and in person on Friday evening. So don't go to the football game that night. Come here for great learning. And then Saturday morning, he's actually going to conduct his radio show live from my campus. So we're really excited about that as well. And then we'll end this series on September the 25th, which is a Friday. And we have another day-long session on building energy smart homes in Cleveland and Bradley County. And for those of you who do build, or you're getting ready to build and really want to make sure your home is built correctly, you do not want to miss that. The afternoon portion is going to be probably more technical and way over my head. I know based on talking with Doug Don Wyatt, one of the building inspectors here in our community, but it's going to be just phenomenal, and he spent a lot of time pulling together just an amazing group of panelists and facilitators to be here on that day. So come back for any of these events. All of them are free and open to the public. Tell all your friends and family to come and learn with us, because that's what we're all about through the series, is trying to give you information to make informed decisions. We only have one Earth, one planet, and it's up to us to protect it. So, and the grant also is providing, see, this grant is wonderful. Don't y'all hope we get more opportunities? But for being here tonight, you get a wonderful little take-a-home, so you can start doing some of those simple things they were telling us we can do. How about a weatherization for dummies kit? We have one for each of you tonight, and it's got some caulking. That's a simple thing we can all do. Some weather stripping, and those outlets that let all that air in. We got those little plates. You can put on those to keep the air from seeping in. So come up and make sure you do not want to leave without your wonderful kit. And then we thank ARC for that generous grant that our campus has received, and none of this would be possible without them. So thank you all for being here, and can we give our wonderful panelists another round of applause? Thank you.
Thanks, fellas.
And Jerry, my husband Dennis.
I wasn't talking about.
Yes, sir.
You're the solar, right? I can't remember.
I am, Callaway.
Listen, I have,